Hi guys, good morning or good afternoon. Please write these notes down before you watch the rest of the video. I do want you to draw this chart out in your notes, space it out, and then please actually draw the graph because that's going to help you on the assignment later on. Once you've written this down, you can unpause the video and I'm going to explain each box and then give you an example and explain it in further detail. So go ahead and pause if you haven't written this down. Thank you. Okay, so we know the general form of a quadratic is ax squared plus bx plus c equals 0, or sometimes we can have equals y, or y equals ax squared plus bx plus c. We also know the quadratic formula at this point, so I'm going to go ahead and write the quadratic formula down here. We know it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I hope you guys can see that on the screen. So if you don't have the quadratic formula memorized, make sure you memorize it before your final because it will be on your final. Now inside of the square root, we have this b squared minus 4ac. We call that the discriminant, and this is the chart that you guys just drew. Now if we pay attention to the value of the discriminant, that can tell us a lot about our graph before even fully finishing the quadratic formula. So if b squared minus 4ac is positive, you're going to have two real solutions, and your graph is going to look similar to this one right here. It's either going to be a parabola opening up or a parabola opening down, where it has two x-intercepts, two real solutions. So we can either get a rational number, like a whole number, or maybe like 1/2, that's a rational number, or we can get two real solutions that are irrational, meaning we could get something like the square root of 5. Square root of 5 is not a perfect square, but maybe we could get the square root of 5 and the square root of negative 5. You would have two real solutions that the parabola intersects the x-axis with. Now let's say if we find the discriminant, and last week we had a specific example where a discriminant was 0, and where the discriminant is 0, that means it crosses the x-axis at one point. And that would actually be called a double solution or a double root, a double 0, because that is where the parabola touches, let's say that that's positive 2. The parabola touches that solution from the right and from the left. So we would call that a double root. Or we could also say that that's one real solution because it's only at x equals 2. Now if we solve for the discriminant and we get a negative number inside of the square root, you're going to learn more about imaginary numbers when you get to algebra 2. But if our discriminant is negative and it's inside the square root, the parabola doesn't even touch the x-axis. So we can have an idea of what our parabolas will look like before graphing them just by solving the discriminant. And that's all you guys are going to learn today. And the assignment that you guys are going to do after the video will be on the discriminant and also the quadratic formula, and how well you know how to solve and evaluate both of those and interpret positive, 0, or negative discriminants. That means that I'm going to have two imaginary solutions and the parabola will not intersect with the x-axis. So here's an example. I'm actually going to have you guys solve this two ways. Let's pretend that we're solving to find the roots. Find the roots. You can also be asked to find the zeros or find the x-intercepts. In other words, use the quadratic formula. So write down the quadratic formula, and you guys should be writing this in your notes. Sorry for the tapping. If you can hear the little tapping on the screen, that's my Apple Pencil. I try not to write very hard on the iPad, but it happens. Okay, so let's work with the quadratic formula, but I also want you guys to interpret and tell me something about the discriminant. So find the discriminant first before you do the quadratic formula. And remember, the discriminant is just the stuff that's inside of the square root, and you're just trying to interpret what the graph is going to look like of the parabola. So we have b squared minus 4ac. And I notice that my example is already in general form. Remember, if I would have been given this, like if I would have been given 5x squared equals 3x minus 6. That's not in general form, so I would have to subtract both sides by 3x and add 6 to both sides to get 0 on the right. But since it was given to me, I didn't have to move anything. That's just a quick little review right there. Because this was given to me, I don't need to worry about rearranging. But if I didn't have equals 0 on the right or equals 0 on the left, then I would have had to rearrange and get all of my variables and my constants on one side of the equation and 0 on the other side of the equation. It could either be on the right or the left. It doesn't matter. Okay, so my a value, since it's all in general form, my a value I know is the number that's in front of x squared. Remember, ax squared plus bx plus c equals 0. So my a value is 5. My b value is negative 3. And my c value is positive 6. So I have a equals 5, b equals negative 3, c equals 6. Now let's plug it in and we're going to interpret the discriminant first. So we have negative 3 squared, because that's my b value, minus 4 times 5 times 6. And let's just multiply from left to right. Negative 3 squared is positive 9. Minus 4 times 5 is 20. 20 times 6 is 120. And then 9 minus 120 is negative 111. So I already know that my discriminant is negative. So if my discriminant is negative, if you look at the first slide, so I would say I have 2 imaginary solutions. Or we can also say we have 2 complex solutions. Now let's go back to our quadratic formula, and this is how we would solve them with the knowledge that we have right now. This is how we would solve this. Let's plug in. So we have x equals negative 3. Notice how I'm using parentheses when I plug in my numbers. And then I already solved my discriminant. I found it to be negative 111. So just leave it like that, negative 111, because I already solved it over here. And then I have all over 2 times 5. So let's rewrite this. Let's clean this up. I have x equals negative 1 times negative 3 is positive 3. Plus or minus the square root of negative 111 all over 10. So with the knowledge that you guys have right now, we're not actually like simplifying that negative 111 inside that square root. We're just going to rewrite it. 3 plus negative 111 over 10, and 3 minus negative 111 over 10. You guys will not have a question like this on your final, like this complicated. But you should know how to interpret the discriminant and what a negative value means inside the discriminant. And it means 2 imaginary solutions, which means that the parabola won't even touch the x-axis. Okay, guys, so you're going to be doing a quizzes after this. It's a short quizzes, and then I want you guys working on your study guide, studying for your final, and getting all those missing assignments done if you have any. If you don't have any assignments to do, then you're going to be working on the math-based diagnostic. Good luck.